Hi, good morning, Lakshanya.
Good morning, sir.
So, can you tell me about how you attempted that problem?
Yes, sir. First, I took determinant of adjacent of AB as determinant of adjacent of B into determinant of adjacent of A. And then determinant of adjacent of B is already given, which is R to the power 5. So I had to find adjacent of A, but I couldn't find the value of alpha. So
I was facing the same problem about reduction. I couldn't, what I thought was, what I'll do is, determinant of adjoint of AB is nothing but determinant of AB squared, right?
yes, sir, we can write it like that also.
So determinant of AB was R cube. Where did I get that from? AB is given to be Ri. So determinant of AB is R cube. And then
Okay, sir. Yes, sir.
put that in, and then I got this is R power 6. So I got everything in terms of R basically. Determinant of A,
Yes,
determinant of B, whatever you want. So I just needed to find the value of R. So what I was thinking was when you multiply both these things, right? You get R into A, which means only the diagonal terms will be R and the other terms will be
0.
0. Okay, I think I got my mistake. Wait 1 second.
Yes, sir.
What do I do here? So it's not 1 here, it's R. Okay. All right. So I simply multiplied just to get the feel, okay? Right? So the idea was B 3 2 was given to me. Or 2 3, yeah? Which one was given to me?
3 2, sir.
Huh?
3 2.
Third row, second column. Okay. So this
Yes,
was
sir.
given to me as minus 3R by 2. So basically, I know that this column, the values will be 0, R, and 0.
Yes, sir.
Okay. So from there, I thought I'll find B1 and B2, but I don't know. Okay, yeah. So the idea was I had gotten a relationship between alpha and R, right? So alpha and R, where was the relation? So yeah, what I did was I found determinant of A to be root of R, R power 1 by 2. Did you get this part? R power 1 by 2?
No, sir.
No, huh? Okay. So what I did here was pretty simple. Adjoint of B is determinant of B squared.
Yes, sir.
Okay. And 1 second. How did I get this? Adjoint of B is R power 5. Was it given in the question? Let me check the question.
Yes, sir. Yes, sir. It was given.
It was given. Okay.
Adjoint of B is equal to.
Is equal to R power 5. So determinant of B should be R power 5 by 2. Right?
Yes, sir.
So determinant of AB is R cube. Okay.
Okay,
So
sir.
determinant
Yes.
of A should be R raised to half. When I
Yes.
evaluated this determinant, I got minus alpha minus 2. So I get a relation between alpha and R.
Okay, sir.
Okay. So the
Yes.
thing is, if I find alpha, I am sorted. Okay. So
Yes, sir.
here, I found one mistake that I did here. Thank you for that. So here I'll be trying to figure out what alpha is. For that, I'll use the bottom two equations. Okay, there is no alpha in the bottom two equations. I can find B12 and B22. Okay,
Yes,
so
sir.
let's do that right now. Okay, B12. Not fully comfortable with the features here. Give me a second.
Yes.
Yeah.
Sir, even I tried the same way, sir. I equated the B's equation and I got a relation between B12 and alpha, sir. But then I think that's wrong because anyway we have to find
B12?
alpha.
No. So, what do I say this? I think we are very close to the answer.
Yes, sir.
That's why I
I'm
said
not
let's.
sure what the answer is. I couldn't find the answer. I only know the options.
Okay, but if one of the options turn out to be one of our answers, it's probable that we have our answer, right?
Yes, sir.
Okay. So still be hopeful. One. So yeah. Here I have B12. Oh, what am I doing? Okay, yeah. B12. One. Just 1 second. Okay, just solve these two now. What are you getting? Tell me. Okay, 3B12 plus B22 equal to 3R by 2. Fine. So like that is 6B12 plus B22 equal to 3R, just to remove denominator. And this side, what do I get? I get B12 plus 2B22 equal to 11R by 2. So like that 11R, this becomes 4. 11R by 2 will keep it. Now, the first equation, I'll multiply with 2 again. So that becomes 12B12 plus 2B22 equal to 6R. Subtracting both, I get 11B12 equal to 6 minus 11, 6 minus 11 by 2, which is R by 2. So I got 11B12. Okay, so I got B12 as R by 22. So put this here to
Yes.
get B22. B22 is 3R by 2 minus 3B12. Comes 3 R by
R by
22.
22.
This becomes 33, and 33 minus 3 is 30 R by 22, which is 15 R by 11. Okay, put these values in the first equation to get alpha.
Yes,
Alpha
sir.
into B12 is plus 15 R by 11.
Sir, we already had a relation between alpha and R, no, sir.
Yes,
Alpha
yes,
is
yes. I'm
equal
bringing
to
another
R.
relation between alpha and R to solve for both.
Okay, sir.
Right. So here R is common for each. R goes off.
Yes, sir.
Okay, so alpha by 22 equal to 33 by 11 minus 15 by 11, which becomes 18 by 11. And alpha becomes 36. Okay. So
Yes, sir.
I had, what is the relation? R raised to 1 by 2 is minus alpha minus 2, right?
Yes, sir.
Yo. R raised to 1 by 2 is,
Actually, we have to find
yeah, tell me.
a determinant of adjoint of AB, sir.
Yeah,
So
yeah, yeah.
after that, we have to substitute.
So we got this as R per 6, right?
Yes, sir. Yes, sir.
So if you find R, we are sorted basically. So here, our alpha is 36. So I'll write this as minus alpha minus 2 raised to 6. No, man, this is not the answer. This is not the answer. It's not there in the options. Shall we try this again quickly? Like, were you getting the same equations? Tell me that much.
Sir, I think so, sir. Because I erased it. I did it so many times and I erased it.
Yo, second, where's your question? We'll do it one more time. Nobody has joined, no?
Yes, sir. Yes, sir.
This is multiplied by Bij. Okay, 3 cross 3. Now we are drawing the second column. That is our plan. Okay, second column means here the terms will be B first
B11.
second column, B22, B. Okay, so these are terms I'll multiply each with. So alpha B12, B22, 2, B32. Very careful. Okay, just find. If any mistake is there, just tell me. Okay.
Yes, sir.
Now, B12, 2B2, 3B32 equal to R and 3B12 plus B22 B32 equal to 0. And B32 is minus 3R by 2, right? So this comes here as 3R by 2. This is
Yes, sir.
minus 9R by 2. So this comes here as 9R by 2. This is 3R. Right? Much we have. Did we use the same equations? Okay. We'll try again. Still somewhat hopeful. Okay. So yeah. B12 plus 2B22 equal to 3R. This is the double of this. And then this one is, okay, I'll subtract this from this. And then I get 5B12. 2B22 cancels out. 3R. Okay, R plus 9R by 2. I should have done this before. So 11R by 2. Okay. 3R minus 11R by 2, which means 6R minus 11R by 2. Right? Becomes minus 5R
Yes.
by 2. B12 minus R by 2. And here I think we have our first improvement. Okay. Right. Then B22 will be 3R by 2 minus 3 into B12, which is plus 3R by 2, nothing but 3R. So B22 is 3R. Okay, our first equation, we'll write it again. Alpha B12 minus R by 2 plus B22 plus
Plus
3R
3R.
is equal to 0, equal to 3R. Oh my
3R.
God. Wow, alpha
So
equal to
3R
0.
will get
What's
cancelled.
going on? Wait. Okay, alpha equal to 0, I can take that. That's not bad. So R is non-zero, right? Something like that was given. Or R is real. R is non-zero. Okay. So
Yes.
alpha is equal to 0. We have R raised to 1 by 2 equal to minus.
So R to the power 1 by 2 will be minus 2.
R to the power 1 by 2 is minus 2. Something's fishy about that, but let's act like nothing is fishy. R raised to 6 is the answer. And then this is raised to the power 12. So 2 power 12 should be our answer, or 4 power 6. That is the option. 2 power 12. So 2 power 12 is your answer. Where did we make the mistake? Minus alpha minus 2. We'll have to find that out. Okay.
Yes.
Wait, where did I travel? Alpha minus 12 minus 2. And when you see that, just tell me to stop.
Yes.
Joint of AB. No, that's not where I got this relation from.
We have to go more up, sir.
Yeah, I found the determinant of A. I wrote the A, this thing, and I found the determinant. I wrote it again. Found the determinant of A. B minus alpha minus. Okay, this is R per half. Okay, where did I get R per half from? Int A. No.
We
A.
got from adjoint, from determinant of AB and
Yo,
determinant of
okay. So, B square, right?
Yes,
Determinant
sir.
of B square is R power 5. So determinant of B is actually plus or minus R power 5. That's where it came from.
Oh, okay, sir.
Okay.
Yes,
Now it's
sir.
solved.
Yes, sir.
I should have solved this faster, but yeah, I'm a little out of touch. But got the idea?
Yes, sir. Thank you, sir.
Yeah.
Sir, there was another question.
Please tell
It
me.
was, what are tautology from the following? And the options were
A tautology means true equal to true, like it's true in all cases. Yeah, what are the options?
It was given similar symbol and then in brackets P arrow mark Q
Arrow up or arrow down?
tends
Or
to
this
Q.
place?
Yes. Then arrow mark on both sides.
Arrow mark on both sides.
No, sir, no, sir. This side also. Um,
Weird.
it's like arrow mark with, it's like a line, sir.
Like this?
It has arrow mark on both sides. Yes, sir, yes, sir.
Okay.
And then again similar symbol Q.
I'll be doing this chapter next. Don't worry. Along with
Okay,
statistics. Right.
This was the first option, and the next option.
That's okay. That's okay. That's okay. That's okay. Let's stop it right here. Harish has joined. So we'll answer this during your this thing when we do that chapter. Okay.
Okay, sir.
So yeah, where were we from yesterday? Doing planes, right?
We did distance between two planes, sir.
We did two sides of a plane. Distance of a point from a plane we did. Now, to equation of plane bisecting angle between two planes. We have a plane bisecting the angle between two planes. So write the notes. Let P x comma y comma z. Let this point lie on the plane bisecting the angle between two given planes. Okay. Let this point lie on the plane bisecting the angle between two given planes, a1x plus b1y plus c1z plus d1 equal to 0 and a2x plus b2y plus c2z plus d2 equal to 0. Okay. You have to find the equation of plane bisecting the angle between these two planes. Remember what we did with line? What do we do with the line? So if you have two planes, so I'll take the line version of it. Okay. Two planes that like it comes out of the screen, just think like that. Okay, two planes. And I have to find some point, I have to find the locus of the point P, which is equidistant from these two. Right? Perpendicularly equidistant. That is what is the angle bisector.
Yes, sir.
All right. So what is this point? The distance. Apply the distance formula between plane 1 and plane 2. Okay, towards this point P. So what do you say here? A1x. So if it's x, y, z is the point itself, then a1x plus b1y plus c1z plus d1 divided by root of a1 square b1 square plus c1 square equal to a2x plus b2y c2z plus d2 divided by root of a2 square b2 square c2 square. Okay, so when we remove this modulus, what happens? I get a1x plus b1y plus c1z plus d1 divided by root of 1 square b1 square c1 square equal to plus or minus 2x v2y c2z plus d2 divided by. Okay, so you get equation of two different planes here. Understand? All right.
Yes, sir.
Pretty easily. So you get two planes. What are the two planes representing? So there are two angle bisectors. Okay, so there's one acute angle and one obtuse angle. So there will be two angle bisectors. Both the angle bisectors are shown here. Is this clear?
Yes, sir.
Okay. Now, bisector of the angle between two planes containing the origin. Now you make sure D1 and D2 are of the same sign. Just make it positive. Simple. Okay, you won't forget it. Then equation of the angle bisector between the two planes containing the origin. Basically, where does the origin lie? Which bisector are we talking about? If the origin is here, okay, if the origin is here, then this is the bisector. If the origin is here, then this is the bisector. Understanding what we are looking for?
Yes, sir.
All right. So we have to find the equation of the angle bisector between the two planes containing the origin. For that, a1x plus b1y plus c1z plus d1. Just make d1 greater than 0. That's it. Okay. So others will change sign. That's all will happen. Divided by root of a1 square b1 square c1 square equal to a2x b2y plus c2z plus d2 divided by. Just remember, make d1 and d2 positive and then put it into this equation directly. We have the angle bisector between two planes containing the origin. Okay. Is this clear?
Yes, sir. So in this case, plus or minus will not come.
Yeah. Like there'll be only one bisector, right? You're talking about. So which one is it was the question? Then you make d1 and d2 greater than 0 and then equate.
Okay, sir.
Then this you need to remember. The bisector of acute and obtuse angles between two planes. Okay. So the steps are this. First is make d1 and d2 greater than 0. The second step is check the value of a1 a2 plus b1 b2 plus c1 c2. Okay. If this is greater than 0, then origin lies in obtuse angle. Right? Origin lies in obtuse angle. And in such a case, the acute angle bisector is given when you make d1 d2 greater than 0 first, then a1x plus b1y. Like you know the rest, right? Divided by root of whatever a1 b1 c1 square. Okay,
Yes, sir.
equal to minus of a2x, and you know the rest. Okay, so acute angle bisector will be with the negative sign. So there was plus or minus, right? One will be acute angle bisector, other will be obtuse angle bisector. So acute angle bisector, when this is greater than 0, will be the negative sign. And so when this a1 e2 plus b1 b2 plus c1 c2 is less than 0, okay. So this is 2a, and for 2b, when a1 e2 b1 b2 plus c1 c2 is less than 0, you say that origin lies in the in the acute angle. Origin is in the acute angle. All right. So here, the acute angle bisector becomes plus. Okay, everything else remains the same. Actually, wait 1 second. I said something wrong here. In this, you don't need to make d1, d2 greater than 0. Just use the two planes. Okay. Right. For the one containing origin, just use the two planes directly.
Okay, sir.
Okay. So here origin lies in the acute angle and you will get.
So, sir, for acute angle only, no, so we have to put minus sign.
No. That is when A1, A2 plus B1, B2 plus C1, C2 is greater than 0. That is where you put acute angle as minus sign. If A1, A2 plus B1, B2 plus C1, C2 is less than 0, then you put acute angle as plus sign.
Okay, sir. And for obtuse, it will be the exact opposite.
Correct. It will be the other one. That's why I just mentioned acute. If I say everything, it will just sound confusing, as if it's not confusing enough already. Okay. Wrote this down?
Yes, sir.
Harish?
So,
Right. Shall I continue to the next topic?
yes, sir.
Okay. So line and plane. Let's begin with the preliminary question. Reduce the equation of lines. Reduce the equation of lines. Okay, in symmetrical form. Okay, write this in the Cartesian format. Come on. So this is a line. Reduce the equation of this line. So this is an intersection of two planes, right? I have to form a line out of this. That's the idea. Okay. Like two planes will intersect in a line. You have to find that line basically. There's a technique here
Yes.
which I want you to learn. Sorry, come again.
No, sir, I told yes, sir.
Okay. So yeah, I'll start anyway. Technique is take z equal to lambda. Okay. Like take any of these as some lambda. Okay. So then what do you get the equation as x minus y equal to 5 minus 2 lambda and 3x plus y equal to 6 minus lambda. Simply add both of them. I get 4x equal to 11 minus 3 lambda. So I can write x or I can write lambda here as 4x minus 11 divided by minus 3. Okay, I can find x basically from this. That's the idea. Next, to find y, what do I do? Y is 6 minus lambda minus 3x. Okay, so here 6 minus lambda minus 3 into x. X is 11 minus 3 lambda divided by 4. Bring that in. Get this as 24 minus 4 lambda minus 33 plus 9 lambda by 4 y. So y can be written as minus 9 minus 4 lambda, right? Minus 4 lambda plus 9 plus 5 lambda is 4y. So here I can write lambda as 4y plus 9 divided by 5. So here I can write this lambda part. Okay. So x minus 11 by 4 divided by minus 3 by 4 equal to y plus 9 by 4 divided by 5 by 4 equal to z, which is equal to lambda, right?
Yes, sir.
Harish, any doubts here?
Got it, sir.
Okay, so you have two planes. You can find the equation of the line, right? Just take any of them as lambda and start solving them like two equations in two variables. And then write lambda in terms of x, y, and z separately. Sort it out. Yeah, so z can be written as z minus 0 by 1, like just to show you how it looks like a line. Yeah, and what you can do is denominator throughout you can multiply by 4. So this will vanish, this will vanish, this will become 4. Right. So
Yes,
without them giving a point or a direction vector, you can easily find the equation of the line using the two planes. Okay. Now, angle between line and plane. Okay, so a line is given to you, r equal to a plus lambda b, and a plane is given to you, r dot n equal to d. Okay. So how do you find the angle between them? So we know that a plane has its perpendicular vector. Okay. A line can go anywhere around it. So when you say the angle between a line and a plane, okay, the angle has a parallel vector as b, and we have this being having a perpendicular vector as n. Okay, the plane having perpendicular vector as n. So we are looking for the angle between b and n? No, we are looking for the angle 90 degrees minus the angle between the vectors b and n. Got this? Like this will be the angle between the line and the plane, this theta. We need to find this theta, right? Okay. But
yes,
this is not the angle between the plane and this vector. It is 90 degrees minus the angle between the plane and this vector. Understood? Okay. So basically, I'm writing this as cos 90 minus theta. This is where I get sine theta from. Okay.
sir. I didn't understand that, sir.
Okay. So you have B vector going along this thing. Okay. So how do you find the angle between two vectors? Tell me that. Cos theta equal to this. You find the dot product and divide by their product of the modulus. You get cos
Yes,
theta, right?
yes, sir.
Okay. That's the same thing we're doing here. Like theta is the angle I want. Okay. So I'll call this alpha. Okay. Angle between the parallel vector to the line and the perpendicular vector to this area. Okay, that is alpha. So I get cos alpha as b dot n divided by mod b mod n. Okay. Now I notice that alpha and the angle I want add up to 90 degrees.
But sir, I thought alpha is 90 degrees.
No. Alpha is not 90 degrees. No. Alpha is the angle between B vector. So I am drawing B vector here. Okay.
Sir,
This is the parallel vector
is
to the line.
alpha perpendicular to the plane? Or
Alpha? No, alpha is the
is
angle
it?
between the parallel vector to R, as in parallel vector to the line, and the normal vector to the plane. Okay, let's take the plane of this screen now. Okay. Okay. So
Yes, sir.
here, wait, no. Let's not take the plane of the screen. Let's draw another plane here. Okay. And a line that lies on the plane of the screen completely. Okay. So that line will actually go through this like this. Go through the plane
Yes,
like this.
it can be kept on the plane, no?
No. This plane comes out. Just imagine this plane that I'm drawing here comes out. Okay.
Oh,
Comes out
okay, sir.
and goes in. Okay. So this is where the screen and this plane intersect, this line. Okay. Think like that.
Yes, sir.
All right. So this plane goes like this, and there's a line which lies on our screen like this. Okay. So the line is some A plus lambda B, where this is B vector. B is the parallel vector. Okay.
Yes,
Now,
sir.
I'll just extend this plane. Okay. And I know that for this plane, the normal vector will come out like this. Okay.
Yes, sir.
Okay. Normal vector will come out like this. I am looking for the angle between this line and the plane. Okay. This is what I'm looking for. Right. Angle between line and plane is what I'm looking for. If a line goes through a plane, what is the angle between that line and the plane? Okay. So this theta is what I'm looking for. All right.
Yes, sir.
But I have the vector n which is perpendicular to it. Okay. So n will be going perpendicular to this. Okay. This is n vector.
Okay, sir. Got it, sir.
Okay. Now got it. So what I obtained by taking the dot product of vector b and vector n is this angle alpha, cos of alpha. Okay. But I need theta, which is 90 minus alpha. Okay. Or alpha is 90 minus theta. So instead of cos theta, you'll write there as sine theta equal to dot product divided by product of the modulus. Got that?
Yes, sir. Got it, sir.
Between line and okay. So just to quickly practice, do this. Find the angle between the line r equal to I cap plus 2j cap minus k cap plus lambda into I cap minus j cap plus k cap, and the plane r dot 2I cap minus j cap plus k cap equal to 4. So find the angle between this line and this plane.
So,
Hmm?
his angle cos inverse 4 divided by 3 root 2.
4 divided by 3 root 2. Cos inverse, sir. One second. 9. No, it's not. It's not. Look, this is B vector. Well, I'll just calculate it actually. Wait. So we have sine theta. Like we understood, right? Between line and a plane. Just think about that. From the plane, you get the normal vector. So sine theta will be equal to dot these two. So when you dot these two, you get 2 plus 1 plus 1 divided by modulus of each. Root of 1 plus 1 plus 1, root 3. Root of 2 square plus 1 plus 1, which is root 6. This becomes sine theta equal to 4 divided by 3 root 2. This becomes 2 root 2 divided by 3. Sine theta is 2 root 2 divided by 3. So theta is sine inverse 2 root 2 divided by 3. This is what you get. Check where you found the mistake. Did you find the mistake? Some calculation error it might be.
Yes, sir.
Got it, huh?
Yes, sir.
Okay. What did you do?
So I did cos theta is equal to m1 vector into n2 vector by mod of instead of
Which
sin
vector?
theta, sir.
Oh,
Instead of
but
sin
no,
theta,
you should
use
get
cos.
at least 2 root 2 by 3, right? You should get 4. Oh, you said 4 by 3 root 2.
Yes, sir.
Oh, you said 4 by 3 root 2. Okay. Then my bad. Yeah. That's some calculation mistake also. Okay, but yeah, now you got it right. Why we use sine theta?
Yes, sir.
Okay, now comes intersection of line and plane. So there's a line given to you, x minus x1 by L equal to y minus y1 by M equal to z minus z1 by N. And a plane given to you, ax plus by plus cz plus d equal to 0. So how do you solve for the intersection of line and a plane? Okay, where do they meet? So for that, we have to use this line here. You find the general point here. Okay, I'll call this all equal to lambda. And then x will be x1 plus L lambda, y1 plus lambda m, z1 plus lambda n. Okay, for each point on this line can be represented like this. You know this from before, right?
Yes, sir.
Take the point and put it into this line, get a value for lambda and put it back here to get the value. Understood? Understood the process? You have a plane here.
Yes.
The plane equation is that you take the general point on the line and that point should satisfy the equation of the plane. That's the fact. Okay, so you put it there, you will obtain a particular value for lambda. So that particular value of lambda indicates which point on that line it lies. Okay, so lambda, once you obtain it, put it back into the equation, into the point you have. All right, take that lambda, put it back into the point, and you will get the point of intersection between the line and that plane. Following, guys?
Yes, sir. Yes, sir.
All right, I don't need to give separate notes, just this is implied. Okay. Now, condition for line parallel to the plane. What will that condition be? Remember, B vector in this case is given by LMN and N vector is given by ABC. Okay. Condition for line parallel to the plane. What does that mean? Sine theta should be 0, right? Okay. And sine theta's numerator was B dot N, which comes
B
out
dot
to
F.
AL plus BM plus CN. This should come out to 0. Okay. So theta, sine theta is theta 0 or pi. Either is possible. It can be facing this direction or facing the opposite directions. Okay. Facing the same direction or facing opposite direction. That's what I meant. Okay. All right. Now, what is the condition for the line to be lying in the plane. For the line to be lying in the plane. What is the condition for that? So here, line is parallel to the plane. It need not lie in the plane. All right. It's just parallel to the plane. The condition we just learned. What is the condition for it to lie in the plane? First is this one. Okay. B dot n should be equal to 0. That is obvious. It has to be parallel to the plane. Okay. But for it to lie in the plane, what is required? Any point on that line should also lie on the plane. If any point lies on the plane, it means that entire line lies on the plane. First, you check if it's parallel. Okay. If it's parallel, fine. Half the battle is won. Then what do? You take any point on that line. So when you have an equation of a line, you get a point on it, right? X1, Y1, Z1. Use that. Okay. You have a given point. So put the point into the plane. So it becomes AX1 plus BY1 plus CZ1 plus D should also be equal to 0. Got this?
Yes, sir.
You should then figure it out and tell me. Both of you are getting this?
Yes, sir.
Okay. This is a line lying in the plane. Now, write some more notes. Coplanarity of two lines. Okay, so we already know that a straight line x minus x1 by L equal to y minus y1 by M equal to z minus z1 by N lies in a given plane, lies in ax plus by plus cz plus d equal to 0. If what are the condition? Al plus bm plus cn equal to 0, which means they are parallel. And this point x1, y1, z1 lies on this. And ax1 plus by1 plus cz1 plus d equal to 0. Okay. So from here, we continue. Equation of plane containing a line, containing straight line x minus x1 by L equal to y minus y1 by M equal to z minus z1 by N, and parallel to the line x minus x1 by L1 equal to y minus y1 by M1 equal to z minus z1 by N1. Okay. So this plane contains a particular line and it is parallel to another given line. Okay. So for that, what you do is, sorry, x minus x2. X1, y1, z1 means it lies on that only. Okay. Okay. So here you write x minus x1, y minus y1, z minus z1, LMN, L1, M1, N1 equal to 0. Okay. So you can find the equation of a plane given two parallel vectors and a point, right? Remember? What would you do there? Write the parallel vectors below and use the point above, right? In the determinant. We already did this part. This is just another version of this. Equation of a plane containing particular line and parallel to another given line. So we find the point here using the particular line. Okay. And LMN, L1, M1, N1 are the vectors which lie on the plane. Remember how we found the equation of a plane with three vectors on it. Okay. So here the first vector has x, y, z, a generic point. Okay.
Yes, sir. Yes, sir.
So what about equation of plane which contains two straight lines? Containing two straight lines, like the same straight, like it looks like the above straight lines. You do the same equation, x minus x1, y minus y1, z minus z1, or x minus x2, y minus y2, z minus z2, because it's given that both the straight lines are contained inside the plane. Like both the straight lines lie on that plane. Okay, so you can use this here, and then what? L, M, N, L1, M1, N1. That's it. Okay. I hope you're getting a good idea of this chapter now, a firm hold of this. Okay. I'm repeating the same things again and again. Okay, so this should be like striking for you. Now, all right. If R equal to A1 plus lambda B1 and A2 plus lambda B2, okay, R equal to these two lines are coplanar, then we can say that A1 minus A2, B1, B2 is equal to 0. Pretty obvious?
Yes, sir.
Okay. Now from this you can say that A1, B1, B2, just different versions of the same thing, okay, equal to A2, B1, B2. All right. I hope you understood what we did here. This was treated just like a determinant. So hence, are you getting this?
Yes,
Or okay. Now, equation of plane containing these. How do you find the equation of plane containing these vectors? So you use one point and the generic point r. R will be xi cap plus yj cap plus zk cap. So r minus a1 or a2. You can use anything. You can replace r here and then bring b1, b2 and equal to 0. You have the equation of the plane there. Okay, understood? They're all the same, different versions of the same thing. Whatever we learned now. Okay. Please write the notes properly. So you can write this as R B1 B2 equal to A1 B1 B2. But trust me, the first part is more obvious. It looks more complicated, but when you're doing a problem, this will seem more obvious. Okay, here's a question for you. Find equation of plane going through 0, 7, minus 7 and contains line and containing the line x plus 1 by minus 3 equal to y minus 3 by 2 equal to z plus 2 by 1. What do you do here? First write whatever you got here. Okay. So there's a first point which lies on the plane 0, 7, minus 7. There's another point which lies on the plane, which is minus 1, 3, minus 2. Okay. Now we have a vector that is parallel to the plane minus 3, 2, 1. Right? This is the data we have. Okay. From here, we are supposed to look for the equation of the plane. So to find the equation of a plane, what do you need? Two coplanar vectors, like two vectors parallel to the plane and a point lying on the plane, right? We have 2 points lying on the plane and one coplanar vector. How do you find the second coplanar vector? Are you following what I'm saying?
Yes, sir.
Okay. So we have 2 points and a vector which lies on the, okay. So we have 2 points lying on the plane and a vector which is parallel to the plane for sure. Okay. To find the other vector that is parallel to the plane, we simply subtract these 2 points, right? It was there in
Yes.
front of your eyes all along. Okay. So I want you to start thinking like that. To find a plane, all you need is 1 point that lies on the plane and 2 vectors. Okay, we have 2 points, lavish, which means you can simply subtract them and find the other vector. Okay. So to find the equation, what do you do? Use 1 point, x minus 0, y minus 7, z plus 7. And then 0 minus minus 1 is 1, 7 minus 3 is 4, minus 7 minus 2 is minus 5, minus 7 minus minus 2. And then you have minus 3, 2, 1, 0, and that's it. This is your plane. Got this? Like you have to calculate the rest, but you got the idea, right? How to find the equation of a plane.
Yes, sir.
Okay. I hope both of you are like thorough with this. Okay. Like any situation, you can find equation of line, equation of plane, doesn't matter. Just be careful of the language of the question from now. That's it. Okay. Now, do one fun topic. Image of a point in a plane. Okay. So you have some point here. Alpha, beta, gamma. You have some plane given here. We'll be drawing a perpendicular to this, meeting at some foot of the perpendicular L. And then you have to find the value of Q here, which is x1, comma y1, comma z1. This is the image. Okay. How do we go about
Yes.
this? Now, the plane will be ax plus by plus cz plus d. Yeah. It will be x plus by plus cz plus d equal to 0. Can you guys try on your own? Try something out. Let's start with the point L. Don't reach till point Q. Because if you find the point L, you'll get the point Q. Remember what we did in straight lines, right? You remember how we found the foot of the perpendicular?
Yes, sir.
Okay. So just go through those notes. If you don't remember, that's okay. Because right now you will be doing it in such a way that you'll never forget it. Okay. So just go through the notes again. Come on. Straight lines. Like how we find the foot of the perpendicular. Like just apply that same logic here. Okay. This is 3D vector. This is in a 3D vector space. So I want you to apply the same logic here. Can I give you one clue? Or will you handle this on your own?
I got it, sir.
Harish, you want a clue?
Sure, sir.
Okay. So this plane is there, no? Ax plus by plus cz plus d. So what is ABC here? ABC is perpendicular to the plane. Okay. ABC is perpendicular to the plane. Now remember, we are looking for the foot of the perpendicular. Okay. So PL, PQ will have its direction ratios as A, B, and C. That is your clue. All right. That was more than a clue. That was actually an explanation. But yeah. Got this much?
Yes, sir.
Ax plus by plus cz plus d is perpendicular to this. PQ will be parallel to the normal vector. That's the idea. Or PL will be parallel to the normal vector. Okay. As in, I am making you do the derivation on your own. This is what I'm attempting. Okay. So please come on, try. It's okay if you don't get it, we'll do it again. But please try. I want you to try. Rack your brains over this. Come on. We have learned everything necessary to do this. That's it.
So, sir, we can take the intersection of the line and the plane as a point, as x, y, and z or something, and then
What are you looking for finally? Yes. Section of that line and this plane. Hmm.
and then so x minus alpha divided by a is equal to uh, y minus beta divided by b is equal
We're
to
talking about the line, right?
yes, sir, I named the intersection of the line and the plane as x, y, and z.
Line PQ or PL goes like this. X minus alpha
Yes,
divided
sir.
by A
A
equal to y minus beta divided by B equal to z minus gamma divided by
divided
C.
by c.
Harish, you got this much also, right? The equation of the line.
Oh, yes, sir.
Hmm? Okay.
Yes,
Now
sir.
this is actually the line. Hmm? So you will assume a point here. Okay. What did you assume it as? X, Y, Z. Huh?
Yes, sir.
Okay. But that particular point, I'll call it X dash, Y dash, Z dash. Hmm? Okay, for now. Okay.
Okay,
Because
sir.
X dash, Y dash, Z dash also lies on this plane, I can say that AX dash plus BY dash plus CZ dash plus D equal to 0. Okay. So the generic point here, the generic point on this line is nothing but A lambda plus alpha, B lambda plus beta, and C lambda plus gamma. This is important. This is the general point on the line. So this point lies on this plane. We are looking for that particular point that also lies on this plane. So what do we do here? Put this into this. I get A into X dash becomes A lambda plus alpha plus B into B lambda plus beta plus C into C lambda plus gamma plus D equal to 0. And then from this, I can say that lambda will be equal to minus of A alpha plus B beta plus C gamma plus D divided by A square plus B square plus C square.
Yes, sir. And then for the image, we just have to multiply it by 2.
So once you get the value of lambda, what do? You don't multiply lambda by 2, okay? You put it into this point. Okay, you obtain point L. You obtain the foot of perpendicular by using this lambda in it. And then you can easily find Q once you have P and L. Right? P is already given to you. L is something you find. You can easily find Q. Harish, any doubts here?
Got it, sir.
Got it, no? Okay, so
Yes, sir.
let's practice one problem now. Okay, we did the derivation the proper way. Now, find the image of 357. Don't use that formula that you derived. Okay, don't use that formula. Don't even try to remember. In 2x plus y plus z equal to 0. Okay, find the image of this point in this plane. That is the question. Image spelling crazy. Oh, okay, so 357, the point. You have to find its image in this plane. 2x plus y plus z equal to 0. Come on. Like if you are doubtful, just draw a figure. Okay, you have some 2x plus y plus z, and you have some point 3 comma 5 comma 7, whose image, okay, so let's call this point B, let's call this point L, and let's call this point Q. Okay, Q is the point we need to find. L is the intermediate point we will find, we will use. And here we can say that the normal vector is along 2, 1, 1. Okay, so the line PQ, okay, the line PQ is given by x minus 3 by 2 to y minus 5 by 1, z minus 7 by 1. You got any answers? Guys?
Till this
Any
I
answers?
got, sir.
Hmm?
Till this I got.
Till this, there was nothing. Like I gave you time for doing this, sir. Come on, come on, come on. Faster, faster. You can do this. Harish, you got any answer? I'm hopeful this side. Come on.
No, sir, I'm doing so.
Do, do. Come on, come on, come on. You'll realize this is only a few step problem. That's it. Like for some people, it's a very tough problem finding the image. I'm not even kidding. Once you get this, easy it becomes. Come on. What's happening here?
Doing so.
Doing. Come on, come on, come on. You can do this.
I'm getting foot of perpendicular as minus 3, 2, and 4. Minus 3, comma 2, comma 4.
Harish.
So,
Where did you reach? Where did you reach? Are you stuck somewhere?
I found midpoint, sir.
From the midpoint? Okay. So what will the final answer be? Okay, guys, let's check the final answer. We'll do that together. But I will tell you how I want you to solve in an exam hall. Okay? I think you guys have put in the effort. And once you find the point L, like half the work is done. Not half the work, most of it is done. Only one last step is remaining. Okay. So this is actually a tricky question, okay, for most people. But what I want you to do is apply the concept properly. Like first draw the figure in exam hall. No need to write this line PQ is this. you write the general point on line PQ, okay? The point. Don't even write PT in the exam hall, okay? The point on line PQ will look like this. We have the direction vector and we have a point on it. 3 plus 2 lambda, 5 plus lambda, 7 plus lambda. This should be your first step. Got this?
Yes, sir.
Okay, this is your first step. Both of you got this? When you
Yes,
see
sir.
such a problem, just draw the figure out so that you don't need to, overthink and imagine. Just draw it out. Look at it. All right. And then write this much down. 3 plus 2 lambda, 5 plus lambda, 7 plus lambda. Okay. Now what do? Substitute this point into this equation. Then what does it become? 6 plus 4 lambda plus 5 plus lambda plus 7 plus lambda equal to 0. So you get 6 lambda equal to 6 plus 5 plus 7, which is 18. That goes that
Minus
side,
18.
minus 18. So you can imagine that lambda is equal to minus 3. Okay. Lambda is equal to minus 3. Put this back into this point. So L will become, what is the point? We have P as 357. No need to write this, okay? L is, put minus 3. This
Minus
becomes
3,
2,
2 and 4.
becomes 4. Okay. Now, how do you find point Q? Like L is the midpoint of P and Q, right? L is the midpoint of P and Q. So from 3 to minus 3, you traveled what? Minus 6 distance, right? Minus 6 units you went. So from here, you'll go minus 6 again to reach minus 9. From 5 to 3, 5 to 2, you went minus 3. From 2 till this point, you have to go another minus 3. So that will come to minus 1. From 7 to 4, you went minus 3. So from here, you go this thing. You get your answer as minus 9, minus 1, 1. I took 2 minutes with explanation. With explanation. Okay. You will take lesser than that in the exam hall. Okay. You might take a little more time. You might take around the same time because why? You have to draw the figure as well. I didn't count for that time. Okay. Just draw the figure quickly. And this is it. Following?
Yes, sir.
Yes,
All
sir.
right. Practice a few more problems. You'll get the full hang of it. So we'll do one more. We'll do one more. This time, find length and foot of perpendicular from 7, 14, 5 to 2x plus 4y. 2x plus 4y. One second, I'll just put a timer on to see your improvement. Okay. 2x plus 4y minus z equal to 2. And time starts now. One minute, 45 seconds now.
Sir, I found the foot of perpendicular.
What is it?
Even me, sir.
11 by 3, 22 by 3, 20 by 3.
Let's find out. Okay. So the point will be 7 plus 2 lambda, 14 plus 4 lambda, and 5 minus lambda. Okay. Now this lies on this, which means 14 plus 4 lambda. 1 second. 14 plus 4 lambda plus 56 plus 16 lambda minus 5 plus lambda equal to 2, since it lies on this. So here 14 plus 56 is 70, 70 minus 5 is 65. Then you have 21 here equal to 2, 21 lambda. So lambda is equal to minus
I found
53.
my mistake, sir.
Yeah, I'm sure. Lambda is equal to minus 3. All right. So lambda equal to minus 3 means the point here will be 1, 2, 8.
8.
Okay. So this is the foot of the perpendicular. Now the distance between them will be root of 6 square plus 12 square plus 3 square. Please don't think I'm showing off. Okay. But I've solved it in less than a minute. Okay. I'm saying you can do the same. You and I know the same things now. Okay. That is the point here. All right. So what is root of 6 square? Okay. 6 square is 36. This is 144. This is 9. This becomes 180. 189. Yeah, that's it. Right. Got this?
Yes, sir.
Yes, sir.
So I started from 2 minutes 56 seconds and ended up. So it took 45 seconds to solve basically. So that is like when you know what you're doing fully, when you're not tensed at all, when you're comfortable, like when all that is there, that is when it takes like around 45 seconds. Okay. But generally, we can expect it to take around 2 minutes. Okay, you are figuring out the question, you're drawing the figure, let's see what we need to find. All that will happen. So it will take 2 minutes. Okay. So what I would like to tell you is that you guys, on your first like real attempt, okay, took 2 minutes 35 seconds to solve this. Okay, 2 minutes 45 seconds to solve this. All right. You reach the foot of the
Yes, sir.
perpendicular. You got the wrong answer, but you get it, right? Some careless mistake can happen. That's normal. But you took that much to get till there. That time will reduce with practice. Same for each and every type of question you have seen till now. Okay. So please keep practicing more till you become better. Record your improvement. That is your motivation. I'm not even kidding. So yeah. All right, guys. Any doubts here?
No, sir.
No, sir. So,
Yes.
so I had school, sir. Can I go?
Yeah. All right,
Thank you,
Harish.
sir.
Take care. Then Lakshanya, we'll end the class now. Or you want to practice one more
Okay,
problem?
Okay, sir.
Okay. So I'll give the last problem for the day and I'll record your timing. Okay. That's okay with you?
Yes, sir. Yes, sir. Yes, sir.
Okay. Game on. All right. Image. Find image. Okay. Find image of line x minus 1 by 9 equal to y minus 2 by minus 1 equal to z plus 3 by minus 3 in the plane. Okay, now I'm asking you for the image of the line in the plane. Okay.
Yes, sir.
All right. So when I'm okay, anyway, I'm recording a time. No, I'll tell you. The lines should be parallel to each other. That is understood?
Yes, sir.
1 second. Lines should be parallel to each other.
Sir, wouldn't be in the same line? Okay. Got it.
No. So there'll be one plane given to you, and there'll be a line. What you have to find is, does it intersect this or not? Okay. So that thing is there, but I'm telling you beforehand to save your time. They don't intersect and they are parallel. Okay. All right. They don't intersect
Yes, sir.
and they are parallel. So how I found out was that I took the equation of the plane. Plane is 3x minus 3y plus 10z, and there'll be a last term. I'm not saying that so that you don't start solving. Okay, so 3x minus 3y plus 10z will be here, and then there'll be another line here. Okay, that'll be parallel to this. I find that a dot b equal to 0, as in the dot product of the normal vector and the normal vector of the plane and the parallel vector of the line are coming out to 0. Okay. So 3
Yes,
into
sir.
9 into 3 plus 3 minus 30. Okay, it's coming out to 0. So which means the line and the plane are parallel to each other. Now, we have to find its image on the line, in the plane. Okay, so I'm putting the final this thing here, and I will start your timer now. There is a point here, 1, 2.
Sir, I found a foot, uh, 5 by 2, 1 by 2, 2.
5 by 2, 1 by 2, and 2. Correct. So the image will be 1 to 5 by 2. There is a 1.5 gap. So 1.5 gap from 5 by 2 is 4. Okay. So another point will be 4. So we got 5 by 2. I'll write the point down. 5 by 2, 1 by 2, and 2. Okay. 2.5, 0.5, and 2. And we have 1, 2, 3 here. Now, gap is 1.5 plus 1.5 gives me 4. Gap is minus 1.5 minus 1.5 gives me minus 1. Gap is minus 2 and minus 1. So 4 minus 1. No, this is minus 3. 1, 2, comma, minus 3. Okay, that's what the mistake is. So plus 5 is 7 here. Okay. 4 minus 1, comma, 7 is the line. Okay. So the image line will be 4 minus 1, 7. Okay, this will be the line.
Yes, sir.
Understood what's happening?
Yes, sir.
Okay. So, okay, you asked me around 3 minutes 20 seconds. No, 3 minutes 10 seconds. So, okay, that's very good. All right. So, because there were calculations involved, you do this pretty fast. Okay, that's good. Okay, well done here.
Yes, sir.
Oh, yeah. So keep doing more of this, and you'll get the hang of this fully. Okay. Now, what happened? What would have happened if the plane was here? The point actually, okay, there was a line that actually intersected the plane, and you were asked to find the image. What would you do?
We'll take a point.
We'll find the intersection point
Anywhere.
between the line and the plane. Okay.
Yes, sir.
Ah,
And
so
then
you have
we'll put it
point.
in the equation of line.
Exactly. Okay. So you have point, right? You'll find the image of this point, whatever point that is given. You find the image of that point, and then also find the point of intersection of the line and plane. Okay. Once you find the point of intersection, and you have this other point, you have 2 points. You can find the equation of the line. Using those 2 points, you can get the vector, parallel vector. Okay.
Yes, sir. Yes, sir.
It'll be sorted there. Okay. So on that note, let's end the class today. You have any doubts regarding today's class? Anything?
No, sir.
Okay. Then yeah, see you in the next class. Take care.
Sir, when I solve the question papers, if I don't get some questions, can I text you in WhatsApp, sir?
Yes, yes, yes.
Okay, sir.
You might get a reply much later because I'm generally very busy throughout the day. So,
That's okay, sir. No problem.
right. But yeah, if you want resources to find questions, like answers to questions, where
Yes,
did you
sir.
solve that last question from? Where did you get that last question from?
Sir, actually, my aim is JEE paper 2. So I did 2020's JEE paper 2.
Okay.
That was the first question in that.
Wait, paper 2 as in you mean advanced, J advanced.
No, sir. I mean for B arc.
Okay. All right, all right. I think you can easily get that. Not an issue. Okay. I don't know how your physics and chemistry is. Yet I'm saying, okay.
Yes, sir.
Shouldn't be a big deal.
In that,
But yeah.
we don't have physics and chemistry. Only maths we have.
Okay, fine. And like how was your this thing mock test score?
I didn't write any mock test till now, sir.
Okay, so are you willing to give one more attempt? Worst case, there's so many
Yes,
attempts
sir.
available outside.
Yes, sir. I'll be giving attempts.
Then don't worry. You'll be sorted. Okay, now keep practicing. Build your base like super strong. Because if this time it doesn't work out, you are doing 100 mock tests next. As simple as that. Okay. Will be
Okay,
kind of
sir.
untouchable. Okay. Right.
Yes,
So
sir.
that's the. Okay, so keep that in your mind. Be confident and yeah, keep solving. Okay. So yeah, send me questions
Yes.
whenever you get out. Not an issue. Yeah, we'll practice.
Okay, sir. Thank you, sir.
All right then. Take care. Bye bye.